This is for Year 12 Specialist. It comes out of 2A, question number 17. We have a position vector from O to A of A and O to B of B. And we know that OP is 4 OBs. Therefore, P is over here somewhere, where O to P is 4 lots of O to Bs. Q is the midpoint of AB. It's going to be Q. And OR is 8/5 of OQ. So here's OQ, 8/5 is more than 1. So that's where R is going to be 8/5. So there's my drawing. Okay, part A, find O to Q, O to R, A to R, and R to P in terms of A and B. So, O to Q is O to A plus A to Q, which is going to be O to A plus a half A to B, because Q is the midpoint from A to B. A to B is going to equal A to O plus O to B, which is minus A plus B. Therefore, O to Q is going to be A plus a half minus A plus B, which is going to be a half A plus B. So that's O to Q, a half A plus B. If I'm looking for O to R, from O to R, O to R is going to be 8/5 O to Q, and O to Q is this, so it's going to be a half times 8/5 A plus B, which is going to be 4/5 A plus B. That's O to R. What do I want? A to R. So A to R is going to be A to O plus O to R, which is going to be minus A plus O to R. 4/5 A plus 4/5 B. So it's going to be minus 5A on 5 plus 4A on 5 plus 4 on 5B. So minus A on 5 plus 4 on 5B, or 1/5 minus A plus 4B. And lastly, R to P. R to P is going to be R to O plus O to P. R to O will be negative 4/5 A minus 4/5 B. O to P is going to be 4B. So minus 4/5 A, that's 20, so plus 16B on 5, which is 4/5 minus A plus 4B. And that's R to P. Part B, show that R lies on the line from A to P. So, if R falls on that line, the way I can prove that R falls on that line, it's another way of saying that A and R and P are collinear. And that's if A to R is parallel to R to P. if I include R and include R, and I'm going from A to R, then I'm going from R to P. If they're parallel, then they'll form the one line. I know A to R is here, so 1/5 minus A plus 4B, and I know RP is there, 4/5 minus A plus 4B, and since A to R equals 4 times R to P, because that's 1/5 of A minus B, and that's 4/5 of minus A plus 4B, therefore A to R is 4 times R to P. Therefore, R is on the line A to P. State the ratio of A to R, R to P. Well, the ratio is 1 to 4. Since you multiply RP by 4 to get AR. Okay, part C continues. There's a point S such that OS is equal to lambda times OQ. Lambda is some constant, some proportionality. So OS is somewhere along the line O to Q. Since OS is parallel to O to Q and they both involve the point O, so they're on this line. Find lambda so that PS is parallel to BA. So we want S such that P to S is parallel to A to B. Now, since we have some proportionality here, I know that in the past that O to P was 4 times O to B, and since we have proportionality, then O to S will be 4 times O to Q, therefore lambda has to equal 4